Howdy PreCal, it is Ms. Kosh. Today we are going to look at solving rational equations. So the first thing we have us do is, they said, remember how to graph. And they give us this nasty polynomial on top of a polynomial, this nasty rational function. So I'm going to look at this and hope something factors and hope that we can, so let's see what we can do. If I have this 2x cubed plus 4x squared minus 2x minus 4, I'm going to try and factor by grouping. I can factor out a 2x squared, leaving me with an x plus 2. And then I can factor out a negative 2 with an x plus 2. And that's encouraging. So then I end up getting an x plus 2 factors out of both of those. And then I have a 2x squared minus 2. So I could factor out the 2. Actually, let's do that. If I have this x plus 2, I can factor out a 2. And then I'm left with x squared minus 1. And now these are both the difference, these are both perfect squares. So this becomes an x plus 2 times this 2 times an x minus 1 times an x plus 1. Oh, goodness. Okay, so coming back up here, I have a 2 that I have factored out front. Then I have an x plus 2. Then I have an x minus 1. And I have an x plus 1. And we're halfway through factoring. Now let's look at the bottom. Okay, so if I come to the bottom, I've got x cubed plus 2x squared minus x minus 2. What factors? Out of these two, I get an x squared times an x plus 2. I see a negative 1 times an x plus 2. I can factor out an x plus 2 and an x squared minus 1. And I have an x plus 2 times an x minus 1 times an x plus 1. Do you know what? This might have been easier to do. I'm just now realizing what I didn't think of. This is an x plus 2 times an x minus 1 times an x plus 1. Basically, I could have just factored out a 2 from here. If I had done that, let's see, this would be a 2 times x cubed plus 2x squared minus x minus 2. This is exactly what was in the denominator. So, well, I do need to factor this because I wouldn't know where my holes were. So I'm going to have a hole when x equals negative 2, when x equals positive 1, and when x equals negative 1. I have holes. Well, what is this? This is going to look like the line y equals 2. 1, 2. Okay, except, well, I didn't hit the point. There we go. Except we have holes. At negative 2, here's a hole. I didn't draw this properly. At negative 1, here's a hole. And a positive 1. And that's our graph. There it is. That's it. That's the whole thing. Okay, let's keep going. So now we are going to we're gonna solve rational equations. So we need to get a common denominator. We need to figure out what values are excluded. Keep in mind, you're not Chuck Norris. You can't divide by 0. So on this particular problem here, our excluded values are x equals 0, because we can't let x squared equal 0, so x can't equal 0. Common denominator is going to be x squared. And so I can take this whole thing, this 4x minus 1 over x squared equals 3 over x squared. I'm going to multiply everybody by x squared. And then this becomes 4x. This becomes minus 1, because this and this have canceled, equals 3. Okay, we're going to add 1. We're going to get 4x equals 4, and therefore x equals 1. Is that something that we excluded? No, it's not. We're done. Okay, next one. On this one, okay, let's see. So if I take this guy, 2 over x minus 10 minus 3 over x minus 2, I'm hoping that I'm going to factor this. I'm hoping it factors to these two things multiplied together. That would be convenient. Okay, x squared is going to be x times x, 20. I can do negative 10 and a negative 2 gives me a positive 20 when I multiply and a negative 12 when I combine them. And so, sure enough, we're going to multiply everybody by this common denominator of x minus 10 times x minus 2. Oh, I ran out of space. What's my common denominator? Well, x minus 10 times x minus 2, or you could have told me x squared minus 12x plus 20. They're the same thing. Excluded values. You are not Chuck Norris. You can't divide by 0, so we have to exclude 10 and 2. And this other one factor down to 10 and 2 right there also. Okay, so now when I multiply everybody through, This first term, I'm going to have the x minus 10 will cancel with an x minus 10. So I have 2 times x minus 2 minus 3 times, now the x minus 2's cancel and I have an x minus 10. And this is equal to, now my whole denominator cancels with this whole numerator is equal to 6. Okay, I see 2x minus 4 minus 3x plus 30 equals 6. Let's see, this is a negative x plus 26 equals 6. I can subtract away 26. That gives me negative x equals negative 20. Therefore, x would equal 20. Is that a number I need to exclude? No, it is not. We're done. Okay. Excluded values, x cannot equal 0 because, so x equals 0. Anyway, I was writing it one way. I wrote it a different way this time. The excluded value is 0. X equals 0 is what's excluded. Common denominator is x. So I'm going to multiply everybody by x, and I get an x plus 4, plus this x times the x is equal to 6x. Okay, so what's happening? I see an x squared. I see an x plus 4 plus x squared equals 6x. So let's move everybody over here. So I have a positive x squared. Subtract this gives me a negative 5x, and I still have a 4 that's positive on that side equals 0. Okay, so now I see an x minus 4 times an x minus 1 equals 0. So x equals 4 or x equals positive 1. Was that excluded? No, it was not. We're good. Okie dokie. On this one, the excluded values, x cannot equal 0 from right here or negative 1 right there. Common denominator would be 2x times x plus 1. Okay, so if I multiply everybody by 2x times x plus 1, the first term, I have 3 times the 2x's cancel, x plus 1, minus 2x times, well, the x plus 1's cancel, so this is getting multiplied by the 2x that was still there, equals negative 2 times 2x times x plus 1. Okie dokie. I'm feeling very okie dokie today. I don't know what's going on. It's a Thursday, but it feels like a Friday, and I'm just a little loopy. My apologies. And this is equal to, okay, so negative 4x times, so negative 4x squared, and then a negative 4x right here times a 1 is a negative 4x. Okay, oh, look, the x squareds are going to cancel. That's nice. Let's move. Okay, so if I say, well, I see 3x plus 3 is equal to negative 4x. We could subtract this. 3 is equal to negative 7x. Divide by 7. I get negative 3/7 is equal to x. Was that an excluded value? No, it was not. There we go. Okay, these next two, they printed funny on the page. I should have fixed it, and I did not. You know, there's some things worth my effort and other things not. On this one, okay, what are my excluded values? X equals 0 or negative 2. Notice right here I could factor this. This is x times x plus 2. And so my common denominator is x times x plus 2. So if I multiply everybody times x times, I have this x minus 1, where it's going to, when I multiply this whole thing by x times x plus 2, those are going to cancel, and we're left, but we still have this x plus 2. We have a 3 times this x plus 6. Everything cancels with everything is equal to 0. Okay, so I see an x squared minus x plus, so plus x minus 2 plus 3x plus 6 equals 0. Let's get all of our like terms together. X squared plus 4x plus 4 equals 0. Oh, this is a perfect square. X plus 2 squared equals 0. Square root, plus minus. I get x plus 2 equals 0. Subtract, or I could just set this equal to 0. X equals negative 2. Was that something that needed to be excluded? It is. So therefore, no solution. The only solution we got had to be excluded, because you're not Chuck Norris, you can't divide by 0. So this problem has no solution. Okay, 2 more. Here we go. This next one, I see my excluded values are x equals 0 or positive 1. My common denominator is going to be 4x times x minus 1. So I've got all those things. So let's write this again. 6 over x minus 9 over x minus 1 equals 1/4. If I multiply everybody by 4x times x minus 1, oh, I'm sorry, you couldn't see what I was writing. There you go. What's going to cancel here? I'm going to have a 6 times, I'm going to have the 4 times x minus 1. And then I'm going to have a 9. What cancels the x minus 1s? So I have 9 times 4x is equal to, the 4's cancel, and I'm left with x times x minus 1. Okay, so let's clean this up. I see a 24 times x minus 1 minus 36x equals x squared minus x. This is 24x minus 24 minus 36x equals x squared minus x. Oh my goodness, okay. And so let's set everything equal to 0. And then we have a positive x squared. I see a negative 12x, but I'm going to have to add it over here, and there's already, so this becomes a positive 11x. So, right, negative 12. When I add 12 over to this side, I had a negative, yeah. Okay, and then I see a negative 24. I want to move it to this other side, so it becomes a plus 24. 0 is equal to, I see x plus 8 times x plus 3, because 8 times 3 is 24, and 8 and 3 add to give me 11. So x would equal negative 8 or negative 3. Did I need to exclude either of those values? No, I did not. Okay, so those are my solutions. One more, here we go. Okay, let's see if this mess, I bet this factors to those two things. Let's see. This becomes 5 over x plus 1 is equal to 6 over x plus 1 times x minus 3. This is a plus 1, that's a minus 3. Yep, that's good. Plus 1 over x minus 3. Okay, now everybody needs to get multiplied. Oh, my excluded values are x can't equal negative 1 or positive 3. And everybody needs to get multiplied by x plus 1 times x minus 3. I'm sorry, you couldn't see what I was writing. Okay, common denominator, it's this, whatever. I don't feel like writing it. So I have 5 times the x minus 1 plus 1s will cancel. So 5 times x minus 3 is equal to 6. Well, all of the denominator cancels with all of that. Plus, I have these cancel, so I have a 1 times x plus 1 is just x plus 1. I see a 5x minus 15 equals an x plus 7. I'm going to subtract. I get 4x. I'm going to add. 15 plus 7 is 22. It doesn't work out perfectly, but that's okay. I mean, it's 22 over 4, which reduces to 11 over 2, which is 5.5. Or 5.5 or something like that. Is that a number that we needed to exclude? It is not. X equals 11 halves is probably how I'd write that. And there we go. All right. Like, subscribe, comment, let me know how I can help you, and go practice.